Welcome, Michael Wickerson at Wickerson Studios. I have begun a very simple app for running Python using the Rhino3dm files to get everything up and running, and it is great practice if you actually want to learn some development with this, and I'll show the details of it. I basically have a server up and running through Anaconda. I'm working in Visual Studio Code. I'm setting some geometries in a very small window in Rhino because it's very simple work I'm doing. And then I'm working solely in Grasshopper to build a pretty much everything in the Grasshopper canvas files, trying to mimic all of the work that you can get on the Rhino3dm API. So you'll want to go to Rhino Development. You'll click on API, you'll go down to Rhino3dm, and you'll see you have a choice of everything you usually have to go in when you're trying to develop and figure out. I'm going to specify curves and start right at the top with curves, and then do domain, dimension, span count, degree, is closed, is periodic. Kind of run through and show how you can get all of these up so it's not this kind of interface with you, but actually directly in Grasshopper. What I did is a kind of primer to that was up here at the top. I thought it would be best to take a look at all of the things. Okay, so we get our Flask server up and running. We do that through a server by typing in pip install ghop server Flask. Once that's running, you should be able to download from Rhino Compute the example files and get their app file open, and then I'm modifying that. So initially I go in and I'm using GitHub Copilot to do pretty much all the work, all the heavy lifting and error correction and debugging. But you can see that you've got everything from hops, number, integer, boolean, and string. One thing I want to point out is that getting the number, hops number and hops integer correct in your inputs and your outputs is really essential to making it run smooth in Grasshopper. So when we get in here and we actually think, okay, how can we get one of these up and running? It's going to be pretty important to do that. Yes, we're going to mimic a lot of tools that are in the vanilla right here, but the point is you will learn about them. You will have them as small functions so you can start doing things that you are limited by in Grasshopper. The Rhino3dm file is a little bigger subset of Rhino Common, and I'm not going to be using Rhino Common. I'm going to stay simple Rhino3dm. Kind of for those that wanted to play with Python node and stayed using Rhino script syntax for a long time, I find there's a similarity there. Then you want to get into being able to make vectors, points, lines, and curves, and all types of curves, control point curves, NURBS curves, and that's where we'll get, because my first section is going to be solely looking at the class of the Rhino3dm curves. And we'll start with curve domain. And then I'll have my keyword for actually getting into the hops node, which these have been named, and following that path back to that name, which happens to be curve domain T0, T1. That's just what I called it. You can change it in the script and modify it to whatever you want to name these things. But if you're not one that you want to sit doing all this development, you want to have every node available to you, just run the app.py file, and then you can go in here and kind of use the hops node to access everything in Rhino3D 3DM. So I'm hoping this app is really getting kind of framed to what will be very helpful for Grasshopper users to get things running smoother. Now you can still go into hops surface, breps, meshes, and subdivisions. I'm still yet to get to the mesh and subdivision, but we'll get there. We'll just start with curves to begin with, and then you'll be using the hops param access quite a bit. I don't know how much I use default Flask and encoder, even though I see encoder coming in pretty fast in the class of curves. I keep a terminal window here, and I just run this with F5. And I save with Control S, and then I clear down here and leave with Control C. And sometimes I just type clear to get my script back up to the top again. So that's it. So as I went in, I was like, okay, they gave me point at, which happens to be one of the methods for working with curves. So that's a nice example, and you can see the Rhino3dm up and running. They then go on to use a surface 4 point, which shows you a little more complexity, that you have to build things. So smaller things make things. NURB surfaces depend on line curves depend on points, and you kind of work your way back to what you need as inputs and what your output will end up being. Hopefully your output will satisfy one of these things that hops can be inputted and outputted as. And I think that'll get extended as this becomes more and more useful. So what I did initially was I just played around. And you should always do that. You should get in and see if this is at all interesting to you. So this is literally the playground of just seeing what I wanted to do. And what I wrote was just a points node right here. I let GitHub pretty much write it from my comments. Param containers in Grasshopper are represented by lists in Python. Not sure why I left that up there, but anyway, I'm creating point, and you can see that it uses Rhino3dm to create a point. It's dependent on XYZ, and XYZ is a small function here of floats, which will generate those points. And those points are coming out right there, dependent on my number sliders. So that node's working. Whenever you open my script, you're probably going to have to go in and hit path and hit OK, and then you'll have to toggle one of these to get it up and running. So that's a little bit of a pain in the butt, especially when this gets pretty elaborate, because then you'll see all the other nodes kind of default out. And of course, nothing's working here because I'm not running my app. So let's hit Control 5, get it running, and then I should be able to toggle it and get everything up and running since then. And once again, because I opened it, I'll probably have to re-kick it in and get it working. And there you go. And everything kind of jumps. It's like a little shock to make it work. So the next one was create curve, and I used to create line and create curve to keep the same scripts because I didn't want to make it too complex when we get down to creating curve. But obviously, degrees of curves are going to make it from polyline through to. You just want to keep your control points when you get into that one more control point than the degree of the curve you're looking for. But still, we're using Rhino3dm point 3D, not much dependencies. And then you can see that surface 4 point happen again. I created my own surface, which is actually the exact same script of Rhino McNeil's surface 4 point up here. So it's writing itself, it's learning from itself as we go. Creating brep is dependent upon a NURB surface, so I've got to go in there, and from that surface, I'm going to bring it in as a NURB surface, and then I'm going to be able to run that as a surface. And once again, you're going to go in and follow the path, name it what you want, and then I'm just going in here without icons, just putting it up here and clicking over here to change it from icon to text. The next one was creating a line again, which basically I was thinking I better make some more complex. I think I made line after I made create curve. And then I stuck it at the beginning, which I think is very important, creating vectors and planes. Now what I'm sad to say is there's nothing up here for creating planes. Initially, you're going to depend on planes. So planes aren't there yet, but I think planes are essential, especially for anybody with robotics interest and toolpath interests. So that's it. So that was all up and running. Those were my tests, and I figured, well, let's start. Let's get in there and let's make curves. Let's use our little ASCII format and say, let's go in, take this text right here directly from the development site, right here. Let's not only put that text in here, so I can use it as a guide. Let's use that text over here to make our GH file extremely readable, and then have our keyword here, and then make sure everything's up and running. You're bringing in proper hops items that you can bring in. So you can bring in a curve, which is cool. You can output a number. You got to be very wary if you want floats or integers, because things will kind of crash on you. And you can debug here, you can debug in the terminal window, or you can debug over here when things are wrong with the comments. But that's pretty simple, 2 outputs, and that's it, T and 0. And what I like about this is even though that's curve domain, this is the vanilla tool curve domain, which depends upon changing the domain, so it has more functionality as an input. But I don't want to get an output that says a 0 to 1, because that's not really good for them processing geometries as radii and lengths and things like that. So I like my outputs as 0, T0 at the beginning, and T1. And you'll see this reflected in the domains, but also getting vectors and getting start points and end points. So what I put in here was the next one, the comment line of going into development, which is right here. Cut and paste it from the development page, Rhino3dm Development page. Bring it in to your Visual Studio Code script. Get yourself a keyword that you know what it's going to be, and then put that over in this window of Grasshopper. Write that again, have your keywords. Make sure when you go into your hops component, literally dragging down a hops component, following the path, you're going to then want to, and I'll show you this one because it's just a hops component. You can tell these all by this little hops that's down here in the corner, and you can see that it's actually parallel processing, which is awesome. And so the path, you've got the name of it, curve dimension, it's running, it's telling me how many dimensions there are to curve. Things that, you got to pick through all these nodes and vanilla nodes and plugins to find. Why not just write one app that serves all curves. Give it a Grasshopper file that you can reference, curves, and everything will be there. So continuing right along, you can see that I've done the same with, and I'm going to go a little faster here, span count, which I've never used in Grasshopper, but here it is. I've got the span count. I've got the degree as we go down, the same comments coming from the development page, and all the way through to tangent end. And then I have to admit I'm down here now, and I got into a static component or function. I thought, okay, method, so what am I going to do with this? I'm going to get caught behind lists, and I'm going to have a little bit of trouble with that. And so GitHub Copilot started to do-si-do here and there and guess at what I wanted. But you can see that all these other ones work. Is closed, is periodic. They're outputting Booleans. And it's a pretty wise program, GitHub Copilot, so it kind of knows what you want to do, but you have to be able to understand enough about programming to debug this and get it to do what you want. And so that's really where my hand comes into play. Otherwise, I'm just hitting tab and enter and cutting and pasting and then getting things up and running. I haven't built any fancy geometries with it, but that's where you can get creative as an architect, engineer, designer, or artist or sculptor. So that's it. As we get through start point, the end point, what I love is you can do very repetitive. It'll start guessing what you want next. Tangent at start, tangent at end. So let's go back into our Grasshopper and we'll see we have those nodes forming. We have the point at start, the point at end sample. And of course, these are all running off of an internalized curve that I put in. And if you ever need a visualization to what's happening, you can always jump in and take a peek back in your Rhino window, which I keep very small here. What I'm finding is those that move away from the Rhino environment into the Grasshopper canvas, move from the Grasshopper canvas into the programming of their favorite editor. So I'm going to use Visual Studio Code, but when I'm studying Python, I usually jump to PyCharm or something like that with Mosh programming. So then you get down to this static create point line, and you've got some weird little things happening here, this list coming in, what's going on, and that's where you realize, okay, as I'm squeezing down through that, I'm going to have to start using what I have. I don't have a hops points. I don't have a hops list. And GitHub will guess at you having that, but you have to remember you have to set those types through something you do have, and you have a hops param access. You're going to set it the list. It's going to kind of dot framework through it and give you what you need to go on, and you're able to take something a little more complex like this script, keeping in mind that your degree has to say +1, which is why over here I've worked out a little something that I've always got a +1 or a -1 on the count. So as many counts as there are in the series, which will dictate different points. And then just to make the points a little exciting, I thought, well, let's have the points go up and down in different directions so I can make an interpolated NURBS curve. So if you take a look at this and this, I've got a pretty cool little model here. It's a little tiny in the middle, but it's running through my server. I'm getting an understanding of NURBS controlling a curve, and you start to really be able to gain control of your data. So what I can say at this point looking into this is there's an infinite amount of work, because I think they'll keep developing it, that I can translate and have running on this app, but I'm torn. I literally am torn, which I think a lot of people should be. Should you be going in here and trying to output more and more complex geometries like lines and planes and surfaces and breps? Or should you, for the sake of doing models and studies, go deeper in Visual Studio Code with Python into the more complex libraries? So you'll see at times I'm going to pull up NumPy, I'm going to pull up pandas, I'm going to pull up and use arrays and series and data frames. I'm going to want to go into more information about machine learning and knowing how to access text files and CSV files. So you really have to decide in Visual Studio Code which way you're going. And I think that's very exciting, because I am still torn between where I want to go. Because if I'm going to want to go back to the data and only focus on the hops values that are more tied to the top 4, which I was using in another script, hops number, which will handle floats and doubles, hops integer, Booleans and strings, that's fine. But now I'm jumping in the curves and I'm like, how much can I do with this? And then tucked in between that is this ability to work things like points and vectors, and we'll get into that as well, and planes. So how much geometry do you want? I really just want to process numbers and stay to the numerical format of even a Boolean being 0 or 1 with massive amounts of large and big data sets and files, and then use that through something as simple as the subdivision node, Why do I have to generate scripts that'll produce something as complex as this when right there I have one of the most efficient surface generating tools beyond NURBS and meshes stuck between that came out last year, a couple of years ago, that I could just have curves that are driven by data as numbers. So that's where I am, Michael Wickerson at Wickerson Studios, willing to do development for anybody, look into this for anybody, but I always stay busy. I think, you know, the reason this adds up and the reason these exist is because I just keep going with it. I'll probably take my subdivision off. You can see as I stretch down here for curves and focus on Rhino curve class, I'm going to go through and I've just got 1, 2, 3, 4, 5, and they pretty much write themselves. All those curve class things will be done. And when I'm done that, I'll decide, okay, do I want to go to something more complex like surfaces, which will depend on those, or should I come back to points and point clouds? Should I come back to planes? Should I come back to something simpler? So I have a tendency to want to come back to the planes because they're going to depend on vectors and points, and I think that would be fun to run. But right now, let's at least get one done, see if there's any interest online of developing this, and then I will know which direction I should go to keep studying and working. But it's all up and running. It's running really smooth. Everything's running very fast. I can access it anywhere. I can put it on the cloud, put it on my GitHub, and when this is done, I can share this with anybody that wants it, along with the GH files that you can have up and loaded with all of the information really structured so you can get into Rhino3dm development. And then hopefully you'll push yourself by opening up over here a more, say in Rhino into Revit, you want to get farther into Rhino Common, and then you can even extend these libraries and these files. So possibilities are endless. I'm starting to find some focus, but once again, I'm moving back towards numbers for more complex Python libraries, or I'm moving further into geometries for the Grasshopper and Rhino window. I really could go either way. So thanks very much for watching. Michael at Wickerson Studios.